Math 2414, differential equations, video 10, direction fields, slope fields, part 3. You know, as I was sketching all of these, I seriously thought about recording another video showing me sketch all these so you could hear me say the things I'm doing, such as at this point at -3, comma -1/2. Let's see, x is -3, y is -1/2. Well, that's just one, that's too easy. So like this one at -3, -1.5, which is here. You can hear me go, okay, slope is 3, go over 1, go up, 1, 2, 3, put a dot, connect. And if you really look closely in the video, you can see lots of dots all over the place. By the time I got over here, the slopes were so steep, I just almost made them vertical. But anyway, so what do we have here? We have a visual representation of all the different solutions to the differential equation y prime equals y plus xy. And remember that when you solve that differential equation, you pick up a plus c, and each version of c creates a different solution curve. So this kind of represents all of them. How can we find one of them? And specifically, how can we sketch a solution curve through the point 0, 1? Well, the answer is literally a game of connect the dots, or rather connect the segments. If I go to the point 0, 1, which is here, I just kind of follow the slope until it takes me to the next line segment that it points. So here, then it kind of goes there, and then it kind of goes up. And then this one kind of goes here. It looks like it's going to bottom out somewhere here. It almost looks like it's going to be a parabola. Whether or not it's going to be a parabola, I don't know. But if you ask me to sketch a solution curve through the point 0, 1, that would be the best. That would be my best shot at it. Now, normally, the reason you do this is because you cannot find the solution to the differential equation, or it's difficult to find. However, I chose this particular differential equation because it is easy to solve, because it's separable. I don't know if any of you thought that when I first wrote the differential equation, but it is separable, meaning that the derivative's function can be written as a product of functions of a function of x and a function of y. How? By simply factoring out a y. Y prime equals y times 1 plus x. So this is separable. So let's separate it and solve it real quick. We'll have to divide both sides by y, so we'll put 1 over y on the left with the dy, multiply the dx to the other side. And if we integrate both sides, the integral of 1 over y is a natural log of the absolute value of y. And the integral of 1 plus x is going to be 1/2 x squared plus x plus a constant. And since we are looking at the solution curve through a specific ordered pair, let's go ahead and figure out the constant using that initial condition. So we let x equal 0 and y equals 1. We get the natural log of the absolute value of 1, well, that's just 0, equals 1/2 times 0 squared plus 0 plus c. So c is equal to 0. So for this particular solution that has an initial condition of 0, 1, our equation is a natural log of the absolute value of y equals 1/2 x squared plus x. And if we solve this for y by exponentiating both sides, we get the absolute value of y equals e to the 1/2 x squared plus x, which means y is equal to plus or minus e to the 1/2 x squared plus x. But for this particular ordered pair, we need y to equal 1. And if we put 0 here, we get e to the 0, which is 1. And for y to be 1, we have to put the positive. So our solution seems to be y equals e to the 1/2 x squared plus x. And I'll be the first to admit, I do not know what that graph looks like. But you know who does? Desmos. And you know who has access to Desmos? This guy. Well, actually, all of us do. So let's get back on my computer. I'm not going to stop and do another video. I'm just going to move the camera here in a second once I get onto Desmos, just to see how accurate our representation was. As soon as I get into Desmos, I'll move the camera. I'm almost there. I'm almost there. Come on, go. I am there. All right, so let's see if I can get this set up so I can use both hands. Okay. Oop, hold on, came off the tripod. All right. Okay, this will work. Okay, so let's type in what we got for our solution. Y equals E. Look at Desmos trying to graph already. To the 1, impatient Desmos, half x squared plus x. So there is the solution that goes through the ordered pair 0, 1, which you can see pretty readily right here. And there's ours. I didn't quite nail the left half of it because it goes up a little steeper than I drew. You see the left half of this curve kind of gets real steep real fast. I know it's out of focus there. There we go. But, you know, considering that I did everything over here by hand, I'm satisfied with that. I'm okay with that. I do want to do one more thing before we depart. I want to go put the plus C back. Oh, excuse me. I just noticed something. You may notice it too. I can't zoom in once the video is recording. The plus X is not where it belongs. So maybe my answer was better than I thought. I want to put a plus X up here. Okay, Desmos, you think you can outwit me? You cannot. That's one thing I found about Desmos is that if you try to put an addition problem in an exponent, it doesn't know to put the plus up there unless you trap the exponent in parentheses and then do a plus X. I'm feeling better about my graph. There's mine. Focus. There's the actual one. Not too shabby for doing everything by hand. I know what you're thinking. You didn't calculate all the values by hand, you use Excel. Come on, that's arithmetic, and if you don't think I can do linear arithmetic with 1 decimal numbers, you're silly. I do want to do one more thing though. I want to put the plus C back up here. Add a slider and animate the slider to see what all the different curves look like. I think I know what's going to happen. Oh, well, it went off the screen. I need to slow it down. Oh, look at that. Why is it not picking up anything below? We'll pause this down here. Getting pretty flat. But notice that there's things below here that it's not picking up. And remember, when I solved the equation, as soon as it focuses, when I solved the equation, I did have a plus minus right there, but I said that since our particular ordered pair has a positive y coordinate of 1, then it had to be plus there. So by doing this, I've lost all the solutions that have a negative. So let's do this. Let's hit edit. Let's copy this. And we'll put a negative here, and right there, pay attention. There we go, right there. We'll add the slider. And now you see I got the picture of the graph below, and if we animate it, we'll see both the top and the bottom solutions at the same time. Let's do one more thing. Let's not let this get ridiculously large. Let's go from -10. Actually, let's go from negative, I'm not sure what's going on here. Touch screen, that's what's going on. Let's go from -20. I get the feeling most of you have stopped watching the video already. And let's just go to 5, and let's animate that. All right, so there's the large value of C is getting flatter and flatter, which makes me think as the C goes to infinity, this approaches the x-axis, and we're getting all the curves that are represented up here. So let me get back in front of the camera just for a second, as my camera tells me I'm at low power. It's okay. All right. So, as I was saying, the best way to get a visualization of a direction field is actually to find technology that allows you to type in the equation or the expression that your derivative is equal to and say direction field or slope field or whatever they're going to call it, and then it makes this nice little picture here. We just happen to be able to verify that it was correct because this differential equation was separable, and therefore we could solve it using the only technique that we know so far, which is to separate and integrate. And that's the end of this series of videos.